In the previous part, we talked about code review as a process. Now, let's explore what are the tools that are available to us to perform that process. There are many tools available for code review, ranging from manual reviews to automated tools. But some common ones that we generally use are these. We have PMT, a static code analyzer. Then we have check style as well, again for the static code analysis. Find bugs is a good tool for analyzing the bugs. And for reviewing the pull request, we have GitHub, GitLab, Bitbucket, and other version control systems. Crucible is a good tool, and Garrett provided by Google is again an interesting tool to perform the code review. So, if it appears to you that code review is a manual review process and there is no need for any kind of tool to perform that, then one must keep in mind that most of the fundamentals of code reviewing can be automated by the tools like PMD, check style, and find bugs. Why automation? Because automation not only increases reliability in the detection of issues, but it also frees time for developers to conduct code reviews that focus on aspects of code that human excel at, like reviewing in the context of the bigger picture, or mentoring a fellow engineer with guidelines and maxims on the best practice. So, a human developer should be leveraged for performing a code review for the things that are beyond the control of the tools, like reviewing a code in a larger picture, reviewing the code by keeping the project specific requirements or the delivery specific requirements in mind. And for the other things that are static, like the code, the bugs, and performance and maintainability, and all that, one can consider if available using an automation tool. That's the usefulness of these tools. So, if we talk about PMD, PMD is a static source code analyzer. According to the project's website, it finds common programming flaws like unused variables, empty catch blocks, unnecessary object creation, unused private methods, and host of other bad practices. PMD features many built-in checks or rules, and an API is provided to allow you to build your own. It is most useful when you are into a CI process because it can be used as a quality gate to enforce a coding standard. In addition to running PMD as a build plugin, we can also configure it to be run during the reporting phase. So PMD does not officially stand for anything basically. There is no such specific meaning of the word PMD. Several retro acronyms have been suggested, including the programming mistake detector or the project meets deadline and all that. But as such, it is just an acronym that does not officially stand for anything. The next tool is check style, which is kind of a coding standard enforcement tool. It's a tool to help you to write Java code that adheres to coding standard. It automates the process of checking Java code to spare humans of this monotonous task. It is highly configurable and can be made to support almost any kind of coding standard. Then we have the find bugs, which is again a static analyzer for bugs. And this tool operates at the Java bytecode level if you're using Java application. PMD and Finebugs share many similarities, but each has its own strengths and weaknesses. So, if we talk about at a very broader level, Finebugs identifies issues in three broad categories: correctness, bad practice, and dodginess. So, it looks for the bugs that are apparent coding mistake, resulting in code that was probably not what you intended. Then it also look for the bad practices like violation of recommended and essential coding practices. And finally, it also look for the dodginess in the code, a code which is confusing, anomalous, or written in a way that lends itself to errors. So these are the things that are generally found by the find bugs, and that helps a lot. in the code review process. Next, we perform the reviewing pull request. So basically, we review the pull request done by the developers, and modern self-hosted or SaaS-based the version control systems like GitHub and GitLab allow the developers to not only create pull requests but also facilitate discussion around these requests. They help to create a record of the conversation around a given change and also provide a history when the change was made and why. And this help in the CI process a lot. Next, we have the Crucible. So, Crucible provides a web based interface for reviewing the code changes. Developers can create review requests for change sets, commits, or branches. And then they can also invite other team members to participate in the review process. Reviewers can leave the comments, suggest changes, and discuss the code changes in real time. So, overall, Crucial supports inline commenting, code highlighting, and code diffing, which makes it easy to review the changes and provide a better feedback. Next, we have the Garrett, which is also called an opinionated review tool. It is initially created within Google. It provides a web based code review and repository management for Git. As discussed on the Garrett website, when a developer makes a change, it is sent to this store of pending changes where other developers can review, discuss, and approve the change. Garrett also captures notes and comments about each change, and after enough reviewers grant their approval, the change becomes an official part of the code base. So, these are the popular automation tools that are available for a code review process, and that helps a lot in the process. They help us to identify those aspects that are otherwise left unchecked by the human eyes. Whenever we talk about the code review process, the question of false positives comes to our mind. So, what are the false positives? False positives are those things that are flagged as positive by a particular tool, but that is basically not a positive point. So, all the code quality automation tools that we have discussed can result in false positives when an issue or bug is flagged incorrectly. This often occurs when we are dealing with the obscure dependencies within Java or when we are optimizing the code for performance reasons. But at the same time, all of the tools that we have discussed can be configured to minimize these false positives. So one must not be discouraged. If you have added the automated code analysis tool and none issues are found, then you must keep in mind that there can be a possible issue of a false positive. Configure your tool to detect that. Usually, after a few runs, we can easily identify the false positives and adapt accordingly. So, that's all for the code review. Earlier, we discussed the process, and in this part, we covered the tools. The combination of the process and the tool makes a code review process complete. So, if you will ever task with such a task of performing a code review, don't go by absolutely manual or absolutely automation based. Perform a mix of the two sides.